The Huntington-Hill Method is a mathematical approach to fairly apportioning U.S. House seats based on state populations. It defines apportionment by using geometric means to determine when a state should receive an additional seat, ensuring a more balanced allocation than simple rounding. This method relies on quotas, geometric means, and modified divisors to prevent over or underrepresentation. By applying these principles, it ensures fair political representation and provides insight into how seats are distributed.
The Huntington-Hill method, sometimes called method of equal proportions, is the highest average method for assessing seats in a legislature to political parties or states. Since 1941, this method has been used to apportion the 435 seats in the United States House of Representatives following the completion of each decimal census. The method minimizes the relative difference in the number of constituents represented by each legislator. In other words, the method selects the allocation such that no transfer of seats from one state to another can reduce the percent error in the representation for both states.
The Huntington-Hill method is a method used to apportion seats in a proportional representation electoral system. It is named after American mathematician Edward Vermilye Huntington and American statistician Joseph A. Hill. It is used in the United States to allocate seats in the House of Representatives based on each state's population. So here are the definition of terms about the Huntington-Hill method. First is apportionment. It is the process of distributing seats in a legislative body among different constituencies based on their populations. Next is proportional representation. It is an electoral system where the number of seats each party wins in a legislature is roughly proportional to the number of votes they receive. Quota. It is the number of seats a state is theoretically entitled to based on its population and the total number of seats available. Next is prioritization. It is the method of deciding which state gets the next seat based on the highest priority score. Priority score, it is calculated for each state using a formula that considers the state's population and the number of seats it already has. The formula is population over number of seats plus 1. Geometric mean, it is the square root of the product of two numbers in the Huntington-Hill method. The geometric mean is used to determine the priority score.
So next is the steps and procedure of Huntington-Hill method. So step number 1, you determine the total number of sets and the total of population. The total of number of sets to be apportioned must be known, and the total of population of each entity must be also available. Step number 2, calculate the priority value for each entity, which is the formula of P, which is the priority value, and it is divided by S times S of 1, which is the value of S as the state. Step 3. You assign the first set, which is the entity with the highest priority value, and it is assigned in the first set. If multiple entities have the same priority, ties can be broken alphabetically. And step 4. Recalculate priority values after each set allocation. After each set of allocated, the priority value of entity that received the set must be recalculated using the new number of sets, which is now S plus 1. So new priority value is equals P squared of S. It is multiplied by S plus 1. Step number 5. Repeat all allocation process. The process is repeated until the all sets are allocated. After each set is given to an entity, the priority values are calculated for all entities. Steps number 6. Final allocation. The final allocation consists of the number of sets each entity receives, which is determined by their calculated priority values after all sets have been apportioned. So it is the final and allocation.
Problem: consider a small country with 5 states, 2 of which are much larger than the others. We need to apportion 70 representatives. We will apportion using both the Webster's method and the Huntington-Hill method. Solution: the population is 610. Dividing this by the 70 representatives gives the divisor 8,714.286. 2. Dividing each state's population by the divisor gives the quote. Quote A, 34.48361. Quote B, 22.95082. Quote C, 5.737705. Quote D, 4.360656. Quote A, 2.467213. Using the Huntington-Hill method, we round down to find the lower quota, then calculate the geometric mean based on each lower quota. If the quota is less than the geometric mean, we round down. If the quota is more than the geometric mean, we round up. As the result of Huntington-Hill method, the apportionment all 70 representatives is divided by each 5 states into the following: State A, 34 representatives as the highest; State B, 22; State C, 5; State D, 4; State A, 2.
The Huntington-Hill method provides a mathematically precise way to apportion seats in the U.S. House of Representatives, ensuring fair representation based on population. By using geometric means and modified divisors, it improves upon simple rounding methods, reducing disparities in seat distribution. This approach helps maintain balance in political representation, demonstrating the importance of mathematical principles in governance and decision making.